Great, thanks very much, David. So I'm just going to be covering the section here with the SR82. Everybody would know the ICP 2002. We've done a revision, which is actually out 7 years now, but there's three main significant changes within the performance of it. So you've got your standards revision, the ICP 2002 to the SR82, slating and tiling. I'm just going to be covering some of the tile solutions for various pitches, ventilation, dry fixings and accessories. A lot of people are going away from the mortar end of it all, going to the dry fitting of it, and then some ridge details as well. So the Irish Standards Recommendations SR82, as I said to you, supersedes the ICP 2002. 7 years now it's out, and I'm still getting some specifications within some drawings referenced in the ICP 2002. Defines guidelines for the materials, designs and applications, recommendations and workmanship requirements for slates, tiles and their associated fittings and accessories used in the construction of pitched roofs and vertical cladding applications of ridge heights not exceeding 10 stories above the adjoining ground. So what you'll see here, the three main significant changes within the SR82 is the revisions to the maps showing the exposure to the sites, to the wind-driven rain and wind speeds. Fixing requirements have been significantly increased due to the map, and minimum batten sizes requirements have been changed as well. So here you can see the old map in the ICP to the new map in the SR. So you can see two zones to moderate exposure and severe exposure, and just wind speeds less than 26 meters per second and greater than 26 meters per second. So you can see that the zone here itself, the severe exposure has increased dramatically, and in turn means further fixings that's required onto the roof. So fixing requirements. Mechanical fixing of the roof covering elements are determined to the following factors. So you got your exposure conditions, and that's based on the map, but not solely on the map, because you could be in the moderate zone, but your roof would still be deemed as severely exposed. So careful consideration to the design, detail and workmanship and the materials in relation to the local exposure conditions to minimize the rain penetration. The roof pitch is based on the rafter, not on the roof covering. Your rafter could be sitting at 25 degrees, but your tile might be sitting at 21 degrees. So it's based on the rafter pitch. The type of the element, which type of roof covering is going to be used in the roof design, anything up to 10 degrees or down to 10 degrees up to 90 degrees. And then the location of the roof of element, which area of the roof is to be mechanically fixed, perimeter of the roof, and then you've got to look at the rest of the area of the roof. And then you've got the height of the buildings. Ridge height compared to the surrounding grounds, is it under 12 meters or is it above 12 meters? So that's the definition, but whether you're going to be deemed as exposed or non-exposed. So here we just take an abstract out of the SR82. So this will cover every pitch on the roof itself. So this top one's fairly simple. Over 55 degrees is deemed as exposed. So that's fairly simple. Every tile head nailed and tail clipped. You've got now 45 degrees to 55 degrees. Your normal location requires every tile head nailed or tail clipped. And then when you go into the exposed zone, it's to nail and clip. And then the majority of roofs around the country is 45 degrees or less. And the perimeter area, which I'll cover later, is basically normal conditions require every tile to be head nailed or tail clipped. Your main roof area, excluding the perimeter, normal locations requires every tile in every alternative course to be head nailed or tail clipped. And then on exposed conditions, depend on whether severely exposed is mechanic fixed, which is head nailed and tail clipped. Now the main difference here within the SR82 and ICP2 is whether your ridges or hip ridges are bedded. You should also be including a mechanical fixing, and that's either by a ridge nail or a ridge screw as well. Just in case if the mortar fails, the mortar will fall out, but the ridge stays in place, so it's causing less harm. Severely exposed buildings. So this is what we're talking about here. Any building which stands above a surrounding or has a ridge height in excess of 12 meters. Any building on a hill slope or hilltop. Any building which is subject to adverse wind effects such as funneling. So you might have a development, and whatever way the wind's blowing coming through the development, you might have a speed of 20 miles an hour on the outside, but by the time you get closer to the inside of the development, it might be increased up to 30 mile an hour. So just bear that in mind with regards to design and fixing specifications as well. Perimeter area just covered. This is what we mean by perimeter area. So you've got your ridge tiles, you've got your valleys, hips, eave tiles, around your chimneys, and also anything around with the abutments. All them is deemed as a perimeter, and all them must be mechanically fixed. And there's just example, you're either using the nails, which is all aluminium ring shank nails, better pull resistance from it. And then you'd also use these clips as well. So you can see some of the range of batten clips that would be used. So you've got your batten clip holding down to stop any uplift. You've got your eave clip as well, another batten clip. Verge clips, if you do have to go mortar in it, you use the verge clips to hold the tiles in place. And then these here clips as well, which we're doing as well, and where you do around the hips and the valleys to stop any small cuts slipping. Your clip would go underneath the tile, hold it in place, and fix it into the hip rafter itself. And then this is an example here of a clip being fitted on the roof. Your standard tile is fit. You'd have your minimum, say 100 mil headlap on here. You'd have your batten clip over the interlock, comes down, and then it's nailed into the batten below. So for example here, you'd have batten 2, batten 1, row 2 being held down by row 1. And you'd see a lot of that where you'd have high winds in certain areas. In one elevation, you'll have a positive pressure going into the roof. Come over the ridge line, you'll have that negative pressure. And that's trying to lift the tile up. So even if the tile is nailed, even if the tile is nailed, you'll have that wind trying to lift the tail of the tile up. If the clips aren't put in position over a period of time, you might have a bit of tile dislodgement, or the tile will lift up, slap back down onto the tile below it. And what will end up turn is the interlock might break, or the tile might crack in half, and then you'll have further leaks. So it's to prevent all that from happening. The next main change there that we've seen in the SR82 is the batten sizes. So the first code we had out was a 2x1, which was probably around about a 22, 25 mil batten. We went up to a 2x1.5, and they range from 34, 33, 32 mil batten. So the batten sizes now for a single lap tile is a 47 millimeter by 35 millimeter. So that's basically a severe difference in the strength of the roof itself, the fitting of the tiles to it, less bounce on the battens, also a safety end of it as well. For roofers up on the roof, he's standing on the junctions, but he's a lot more batten there as well to be standing on as well. But it's basically adequate stiffness to avoid any excessive bounce or spring when the fitting of the tiles. They should have sufficient weight or sufficient width and depth to avoid any splitting or penetration when you underlay it on the fixing of the roof covering. And then also as well is basically we used to have the nominal size and a minimum size battens. We only have one size of batten. So minimum size batten is 47 millimeter. Machine grade timber, battens that are machine graded timber and CE marked should comply with the marking requirements AS EN 14081-1, 47 30 by 35. Strength grade battens are visually graded, should be marked with the following: ID of the producer, graded to SR82, and then the counter batten should be the same width as the supporting rafter, and I have a minimum depth of 22 millimeter. No, the slate there, you can see the slates. Sorry, we're over here. So you got your slates is 22 mil. So 35, 30, so it's. Considerations to consider before selecting the correct roof covering. So the purpose of selecting the right cover is basically your pitch based on the rafter, as I was saying before, the location, and just bear in mind that you could be in that moderate zone, but the roof itself would be created as an exposed condition. The rafter length greater than 5 meters or 10 meters. Big difference when you've got a lot more rafter. For example, this roof here was 25 degrees. It was sitting in a moderate zone, but the rafter itself was 18 meters. So it was under severe pressure within that, but it was still, so consideration should be carried out within. It wasn't a big distance from the beach, but the roof pitch was 25 degrees, but it was the rafter length where there's a main concern. A lot more water coming down the rafter under severe wind and rain, so it's holding it back up, or else the water was blowing across the roof and then flotation within and interlocks of the tiles. So just to bear that in mind. Just some examples here. This is, we'd see a lot rear extensions, wrong covering put onto the wrong tile or onto the wrong roof pitch. Just make sure that correct covering is used for the correct roof pitch itself. There's one example here, just a Centurion, go down to 10 degrees, but we're seeing a lot of re-roofing in that area at the minute. So just make sure that there's correct roof covering for it. Here you see other examples of just the other large tiles formats, 17.5, 22.5, 25 degrees. Every one of them will have a limit. And then you see the double lap tile, the plain tile, again, 35 degrees minimum pitch on that. And again, that's just down to a double lap tile, so there's no interlock, so the tile below it is carrying the water off the roof. So moving on to the roofing system importance of ventilation. So here we've got the building regulations, F, and then F2, condensation in the roofs. Adequate provision shall be made to prevent excessive condensation in the roof or in a roof void above the insulated ceiling. So here we see in the code, you've got your cold roof, you've got your warm roof insulation following the rafter. Over here, you've got a lot of houses here, but I'd call that the hybrid roof. You've got a lean-to or mono roof, and then you've got your flat roofs as well. So for this, we'll take the cold roof where you'd see the insulation following the ceiling itself. What you'd have here is average air temperatures within the buildings have increased, thereby allowing more water vapor to be carried into the air. Higher amounts of insulation being placed into the ceiling levels have led to cooler roof voids. So as to make sure that you have continuous or equal to 10 millimeter airflow at the eaves on both sides. Now, if the building is greater than 10 meters or if the roof pitch is 35 degrees or above, you should have eave to ridge ventilation. Now, I've gone out to a couple of jobs in the past where you'd have adequate eave ventilation, but as soon as the house owner starts putting up boxes and Christmas decorations and everything else in here, it's restricting that crossover ventilation. So it's always good to have that high level ventilation as well to prevent that. Here we got the warm roof. So the difference between the cold roof and warm roof, you'd have 25 millimeter air ventilation at the eave. That's creating a coming across. You've got your insulation up to your ceiling. You create that void across here, 2-inch void coming across in the underside of the underlay above the insulation and comes up and has that 5 millimeter either side of your ridge line. So basic elements of efficient ventilation on a roof space, your inlet at the eaves and your outlet at the ridge. Ventilation of each truss. What I've gone past the times is you've got your eave ventilation here, you throw in a vent tile, but the vent tile will only draw a certain amount of airflow coming from the eave up. What you want is ventilating across truss is not functional. You'll have the underlay going across, you have your battens sitting down on top of it. So if you've got your continuous ridge ventilation, you'll have continuous flow of ventilation from your eave going right up to your ridge line. This is just some examples I've gone out and looked at where basically there was adequate ventilation at the eaves, but the insulation was blocking it. So all it was doing, the soffit ventilation was in place, but all it was doing was ventilating the soffit. So the insulation had to be pulled back to allow that, and you can see the condensation sitting on the underlay. Again, here's another one I've been out, and basically your insulation was pushed out, went back up after January with decorations, and discovered that there was a lot of moisture sitting on the underlay. Again, here bad detailing here at the eaves. So you have no eaves tray, so you could see here that the insulation or the felt had been coming down into the gutter, absorbed a lot of the moisture, rotted away, bad detailing here, and you can see the ponding of the water as well down at the eave. So to overcome that, you ended up going with the dry eave ventilation system. So it's creating a continuous eave ventilation at the eaves. So you either have a 10 millimeter grill, or sometimes you'll have a 25 millimeter grill. You'll have an eave support tray, and you'll have the rafter roll. All that's applied before the underlay goes onto the roof. So this is it in situ. So you have the overface vent grill, eave support tray, you have your rafter roll, and you can see the form of the rafter roll, so it's allowing the air to go up through the section here. So this is when you're in the inside of the attic space looking out, the insulation is put in, it's pushed right out to the back of the rafter roll. Now I've gone out and the overface vent grills in place, the eave support tray is in place, but the rafter roll's not in place. The insulation comes out, pushes right out to the back of the underlay, and again, you've done nothing. All you've done is put all the effort into the eave details with the overface. So here, so if you don't have that rafter roll, the insulation comes across this section here of the felt. All you're doing is ventilating the soffit. So what's important here is the rafter roll comes in different sizes. So you'd have a 400 mil and you might have an 800 mil. So just to bear that in mind, as if you're going to go with the high levels of insulation, you might need to be putting in the bigger rafter roll here to make sure that you're going to have that airflow coming across. And now we move on to the vent tiles. These are now a couple of examples that have gone out. Important to extract pipes are connected to the correct vent tiles and are not left lying over the attic space. Here you can see where there was an extractor here from the shower, come across, the roofer put in the vent tile sitting over here as opposed to right beside it. So instead of moving the vent tile, the flexi pipe was just draped over the attic space. The attic sitting there cold in the winter time, warm shower, that flexi pipe was full of water, condensated water. As soon as you lift it up, or it's going to track back down into the fan, and then just causing potential hazards. So it's important that all extractor pipes are connected to the vent tile. And there's another one which is basically pushed right out to the eave as well. So there's a range of vent tiles. Every one of them is molded and shaped to the exact same tile to the shape of the tile. All weather tested, airflow capacity is all done through it, and you'd have a range of different capacities, 10,000 millimeter airflow, and then for heat recovery systems, 20,000 millimeter airflows. You've got insulated flexi pipes as well, and then you've got your 20,000 millimeter here, and then you've got your joiners and connectors. But it's just to make sure that you use the whole components that are from the extractor unit to the vent tile. And again here, there's it in situ. Connection goes straight down, so it's as short as run as possible with the flexi pipe. And if it's just your standard white flexi pipe, sometimes that might need insulated as well. Mortar failure. Unfortunately, mortar will fail even when the roofer has installed it correctly. Structural movement is a common cause in the failure of mortar. Weather conditions is also a key factor in mortar failure. So this is what we're talking about in the SR82, that when the mortar does fail, your ridge tile will still stay in place, but the mortar will fall down, as opposed to having mortar and ridge falling down, causing serious harm to anybody below. To overcome that, you put a ventilated dry ridge system, and this is what we're talking about. So instead of mortaring it in, you'd have an aluminium roll perforated. It allows the roof to breathe as well. But you have the ridges here. So each ridge here is mechanically fixed by 2 hammerhead screws. There's washers into them and all. So that's making those tiles or ridge tiles are well secured, and you're getting that continuous ventilation as well at the high level. And again, here you'd see it with, say for example, we've seen beforehand with the profile filler. There's no sense putting that aluminium roll on a profile tile, because then you'll have these gaps sitting here. So you'll have a filler unit for that to fill in the gaps there, and it'll also make that allowed to ventilate and mechanically fix it. Here's another problem with mortar failure down at the hips. And the problem here, the mortar's come in, moisture's got in, frost has come out and just popped the ridges off the hips. There's another one was more like a dynamo effect. One came out and the whole lot of them slipped down, and you can see the wind got in and started to remove the tiles here as well. So again, elimination is mechanically fix the ridge system. We have a dry hip system here for it. Again, you have the aluminium roll. You have there's the clips that we're talking about. So any wee cuts of tiles should also, if you can't get a screw into them or a nail into them, you put in a clip here as well to stop any slippages. Aluminium roll, you've got a tray here to keep the ridges straight and level going up the roof. And again, each ridge is mechanically fixed in twice. Mortar failure at the verges. You can see here that the roofer had done everything right, put in the verge clips, but just over a period of time, mortar had come loose. So what you'd have here is a possibility of water ingress coming through there, or any birds or rodents. Again, to eliminate that, there's a number of systems out there. We've got either a step dry verge system or we've got a continuous dry verge system, either in a PVC or there's an aluminium flash in there now as well. And you can see here that it's all finished off. And a lot of these systems, particularly in the last 6 months, 7 months, has done nothing but rain, apart from the last couple of days. So these systems can be installed in any weather conditions. So you're not being held up on site, or you're not being, come back and the possibility of mortar being washed out of the roof when it's being done. So you can see here, you've got your dry ridge finished up, your block end ridge, and you've got your dry ventilated ridge as well. So you're getting that complete ventilation from your eave going right up to your ridge tile as well. And again, this is the other system, which is basically a continuous 3 meter length of verge. You can do plastic or metal. And you can see here that it actually also has a verge clip. So you have 2 inches coming across, and it's coming holding down the tile, the cut tile that would be sitting there in the flat tiles. Comes down, you've got your trough as well. So your tiles are cut right out to the out edge of the dry verge. You've got a gap here as well for your PVC fascia board, and then that runs down into the gutter. Another mortar failure there at the valleys. That's a common enough one. To overcome that, there's a couple of different systems out there in the market. You've got your traditional lead, which the majority of people would still use, your code 5 lead on your valley. And then you've got another system here, which is your dry valley system, GRP. You finish it off with an eave closure and a top closure. You cut your tiles all in, and then this is it, and tech drawn for it. You've got your hidden troughs, and then they run down into the gutter. Or else you go with, as I say here, your traditional system here, or instead of, but you'd use your lead valley, or else there is an aluminium trough as well. And instead of pointing in your valleys, you've got a valley trim. So it's an aluminium valley trim. You can see where there's perforations going up the valley itself, or you can't really see it too well there, but that allows any water out into the valley and down into the gutter. So again, it removes the need for mortar. So that's really all the system there where we're kind of half covering. You've got your eave details, you've got your verge details, valleys, you've got your abutments, and then of course you've got your flashings as well. And it's important as well to make sure you use the correct lead, code 4 in any abutments, flashings, and more importantly, code 5 for the valleys. And that code 4, and making sure that the valleys are cut correct lengths, 1.5 overlaps. I've gone out to many jobs where the valley length was a hell of a lot more than 1.5, and there was just that expansion and contraction, and the lead had cracked. So it's just to make sure that the correct materials is used for that. Maintenance, it's one of them things that when you put up on the roof, it's not you just simply walk off and that's it, done and dusted. You should always be carrying out a regular visual inspection of the roof, usually twice a year in spring and autumn. Remove any leaves or debris from valleys. I've gone up more times and the horizontal valley was completely blocked with leaves. Let's make sure that's all cleared so the water doesn't be backtracking up onto it. Check the conditions and security of any tiles, any storms that we've had. It's always good to go out and do a visual check on it. Make sure there's no tiles dislodged or any tiles broke. Accessories, making sure they're all right. Any flashings that's been damaged. And any vulnerable perimeter areas of the roof, mainly your hips, your ridges, the perimeter that I showed before, they're the main concerns that you want to be looking at. And then check the function of any roof space ventilation. Make sure they're not blocked with any leaves or anything like that. Roof tiles covered structurally, 60-year structural guarantee. You'll see they carry all the DOP CE certs. All tiles are manufactured to the latest European standards, EN 490, testing 491. And then products are manufactured to the ISO 9001, 14001, and 50001, which is quality, environmental, and energy management systems. And we'd always say fix in accordance with the Irish Code of Practice for slating and tiling SR2. That's a minimum standard. So you can always go more if you need to, but that's the minimum standard. Don't go less than it. Minimum standard at the minute in your moderate exposure is every second row. All the perimeters fixed and every second row mechanically fixed. A full range of roofing accessories have been designed. It's like everything, and other manufacturers are out there, but we design and manufacture the tile, we design and manufacture the accessories to suit the tile. We have them all wind tunnel tested as what everybody else would be as well, but it's making sure the correct components are used for the roof itself. And that concludes my presentation. Thank you.